Hello mathematicians, we're now going to have a look at what the geometric definition of the parabola is. And the parabola is a locus, and it's the locus of a point that is always equidistant from a fixed point, which we'll see eventually we're going to call the focus, and a fixed line, which we'll call the directrix. So this is that expressed a little bit more formally, that a parabola is the locus of a point P of xy moving so that it's equidistant from 0a, the focus, and the line y equals minus a, and in that case the locus is x squared equals 4ay. So it's a little bit different to how we've written the equation for a parabola in the past, but it is simply y equals x squared on 4a, and that's the layout that we'd be a little bit more familiar with. But this is what we're moving towards, x squared equals 4ay. Let's just have a look at GeoGebra to illustrate this point. So here we have the parabola, x squared equals 19.6 times y, so the value of a is 4.9. So our parabola is going to have its concavity and, if you like, its width determined by the value of a, which is related to the focal length. So we can see this point in red just here. That's the focus, the point 0a, so a in this case is 2.5. The directrix is the line y equals minus a, which is minus 2.5. And P, a point on the parabola, in fact any point on the parabola, is always equidistant from the focus and the directrix. So in fact, as we move P to all the possible positions that it could occupy, such that it is equidistant from the line and the focus, then we trace out the parabola. And the equation of this particular parabola is x squared equals 4a, which is 10 times y. So just revisiting some of this terminology because we need to make sure we get our head around it. So for the parabola x squared equals 4ay, so the example on the right, a is 3, so the parabola is x squared equals 12y. It's going to have a focus at 0a, and it's concave up if a is a positive number, if it's greater than 0. So this is the point 0, 3 on this particular parabola. We're going to have a directrix which has equation y equals minus a, which in this case is y equals minus 3. The vertex is going to be at 0, 0 if the parabola has this form, x squared equals 4ay, so that's obviously a minimum in this case. It's going to have an axis of symmetry of x equals 0 if it's in this form, and it's going to have the focal length as the distance from the vertex to the focus. So it's a units. Now the focal length is just that. It doesn't have a direction. So it's just a units or 3 units. If the parabola, well, and it's always within inside the parabola. So if the parabola is concave up, it will be above the vertex. And if it's concave down, it will be below the vertex. And it will be equidistant from vertex to focus and vertex to directrix. Now there's a little bit more terminology. So you'll remember a chord. We referred to it previously as a secant, so it's simply a line joining 2 points on the curve. And if that chord also passes through the focus, it's called a focal chord. Now, if the focal chord is also parallel to the directrix, it has an even more particular name, which is the latus rectum. And the latus rectum always has a length of 4a units. Now, at some stage, we will prove that point, but for a moment, we can just look at the GeoGebra. So we can see here that when a equals 3, and therefore our focus is at 0, 3, directrix at minus 3, then the latus rectum here, the focal chord parallel to the x-axis, has a length of 12 units altogether, because it intersects the parabola, at 6 units to the right and 6 units to the left. And as we vary the value of A, then obviously we vary both the focus, the directrix, and the length of the latus rectum as well. So let's look at some typical questions. So the first one, a point moves so that its distance from the line y equals 5. So our brain should be starting to say there's something special about that. And in fact, its directrix is always the same. So this is part of our definition of the locus of the parabola, as its distance from the point 0 minus 5. So 0 minus 5, we should again think there's something about that, and the something is that it's its focus. So we have to describe this locus and state the equation of the locus. So a good starting point is a sketch. So we have the focus just here at 0 minus 5. So hopefully we're starting to suspect that this parabola might be concave down. The directrix is the line y equals 5. And we have to move the point so that it's equidistant between them. Now, because the focus is on the x-axis, that means that the vertex is here, midway between the directrix and the focus, and the possible positions for P, so that it's always equidistant from the focus and the directrix, give us a locus which is a parabola. And this parabola is going to be x squared equals, and it's concave down, so it's negative. The focal length is from the vertex to the focus, or from the vertex to the directrix, so it's 5 units. And we know that in general the parabola is x squared equals 4a, so it's 4 times 5, 20 times y. So x squared equals minus 20y is the equation of the locus. Now if we had to derive that, we have to go a little bit more specifically. So again, we start with our focus here, 0 minus 5. Our directrix up here, 5. We put P somewhere. Now it helps if we have a vague idea of where it might be. But if we didn't and we put it up here, that would be okay. And we know that we need these two distances to be equal. So, as we did previously for the first exercise, we start off with our distance equation. So the distance from P to the focus is going to be the square root of x minus 0 all squared plus y minus 5 all squared, and that has to equal the distance from the point to the line y equals 5. Now that distance will be 5 plus, or 5 minus y, because y will be a negative number where I've put it. So that will be 5 minus 5. If we now square these two sides to get rid of the square root sign, that complication, then this term just becomes x squared. This becomes y squared plus 10y plus 25. And over the other side, we've got square of the first minus twice their product plus the square of the second. Now as we then start to simplify, we can see that the x squareds go out on both sides, the 25s go out, so x squared equals, and I shift this 10y over here, minus 20y, as we expected. So, other questions. This one here, what's the focus and directrix of the parabola? Well, we can see, I hope now, that this is a parabola which is concave up. Its vertex is at the origin because of the format that it has. That means that 4a is equal to 2. Therefore, A is equal to 2 and 4, or a half. So the focus is going to be at 0A, so 0, a half, and the directrix will be on the other side of the vertex at y equals minus a half. Now, words around this would be very good if this was an exam, but I'm trying to speed things up for the video. This parabola, hopefully again we recognise that the negative means that it's concave down, but because it's in the format, well, it can be put into the format x squared equals negative 2y. When we multiply this across, then that means that 4a is negative 2. Sorry, 4a is 2, but the negative tells us that it's concave down. So the focus is inside the parabola at 0 minus a half, and the directrix is at y equals plus a half. You may want to do these by just convincing yourself of this with a sketch. Our next one, determine the equation of the parabola with vertex the origin. So that tells us that it's of the form x squared equals 4ay essentially, or minus 4ay, and the directrix is y equals 4. So again, we start just drawing a picture to clarify our thoughts here. So vertex is here, directrix is here. That's telling us we've got a concave down parabola with the focus here at 0 minus 4. So the value of a is 4. So our parabola is x squared equals minus 4ay. X squared equals minus 16y. Now, verify it by deriving the equation from the definition of the parabola. Means to go through the distance formula as before. So this distance and this distance must be equal. So as we saw previously, that means that the square root of x minus 0 all squared, which is just that, plus y minus minus 4 all squared equals this distance, which is 4 minus y units. You may want to again just convince yourself of why that's minus there. Square both sides, so x squared plus y squared plus 8y plus 16 equals 16 minus 8y plus y squared. Gather terms together and we can see that what we get is x squared equals minus 16y, as expected. Now, the equation of every parabola whose vertex is at the origin and whose axis is vertical or horizontal, so we're introducing this now, can be put into one of these four forms. And the four forms are these. So x squared equals 4ay, you should be familiar with. X squared equals minus 4ay, and you're probably not surprised to see that if the parabola is on its side, and it's concave to the right, that's y squared equals 4ax, and to the left, it's y squared equals minus 4ax. All the other relationships between focus, vertex, and directrix hold, but clearly the directrix in the case of the parabola on its side is a line x equals plus or minus a, and the focus is plus or minus a, 0. So for each of these parabolas, we'll find the focal length, then the coordinates of the vertex, the focus, and the equation of the directrix, and then sketch a graph. Now we may not do all of these. X squared equals 2y. If we do that, then we've got 2 equals 4a. So again, a equals a half. So 2 equals 4a, a equals a half. So focus is at 0, a half. Directrix is at y equals minus a half. It's concave up. So this is it. This parabola is obviously the same sort of thing, but it's concave down. This parabola here is a parabola which is lying on its side, and it's concave to the right, and 4a equals 6. So a equals 6 on 4, 3 on 2. So that means that our parabola runs like this. The focus is here at 3 on 2, 0, and the directrix is here at x equals minus 3 on 2. And likewise, you can see that this one here will be a parabola concave left. The focus will be at minus a half 0, and the directrix at x equals plus a half.